In this video, we'll go over the homework that follows the lecture introducing the concept of absolute and conditional convergence. And as always, I hope that you watched the lecture. And let's go ahead and start the homework. So here's the homework. The first question is asking us to identify whether this alternating series converges or diverges, and if it converges, whether it converges absolutely or conditionally. And because this is an alternating series, we're going to use the alternating series test, which has the same setup as the divergence test. So we have to find this limit of a general term without the alternating sign, and if it's equal to 0 and then the series is positive and decreasing, then we would conclude that it is convergent by the alternating series test. So what we're going to do is, well, to find the limit, it's pretty straightforward. It's 1 over infinity, so it has to be equal to 0. Now we can verify that it's positive and decreasing, and therefore by alternating series, this series converges. The alternating series converges. Now it could converge conditionally or absolutely. So to identify whether it converges conditionally or absolutely, we have to now consider the series made of the original series by removing the alternating sign, and now this is just a regular series, so we're going to use the limit comparison test, and we're going to establish that this series behaves exactly the same way as this series. And what's special about this series is that this is a p-series with p equals to a third, which is greater than 1, meaning that this p-series converges. So let's establish this. To establish this, we have to find the limit as n goes to infinity, and we're going to take the general term of the original series and divide it by the general term of the series against which we make the comparison, and this limit as n goes to infinity will be equal to n to the power 8/3 divided by 4n to the power 8/3 plus 3, and the limit is equal to 1/4, which is a number between 0 and infinity. Therefore, we established this equivalence in terms of their behavior. Therefore, this series converges. And because this series converges, we conclude that the original alternating series converges absolutely. So the answer is this series converges absolutely. So it's a lot of work for a multiple choice question, but that's how we identify whether a given series converges conditionally or absolutely. And by given series, I mean the alternating series. All right, another one, very similar in terms of the setup. So we recognize this as an alternating series. So we're going to use the alternating series test, which, when certain conditions are satisfied, will allow us to conclude that the series converges. So we find the limit of the nth term. The nth term goes to 0. And because it's a positive and decreasing series, we conclude that the original series converges. Now, to identify whether it converges conditionally or absolutely, we have to analyze the convergence of this series, and this series behave exactly the same way as this series, which is P series with P equals 1, and because 1 is less than or equal to 1, this is a divergent P series. But we also know this series as a harmonic series, so it diverges. And now to establish this equivalency in terms of their behavior, we have to set up this limit as n goes to infinity, 1 over 7, 8 plus 8 over 1 over n. By now we are more comfortable with these types of limits, and this is a number less than infinity, greater than 0. So we established this equivalency, and now we conclude that this series diverges by the limit comparison test, and therefore the original alternating series, while it converges what we call conditionally. All right. Another alternating series. And we're going to set up the alternating series test. And in that test, we're going to find the limit as n goes to infinity. And of course, this limit is 0. And we're going to verify that it's positive, check, and is it decreasing, check. So by the alternating series test, this series converges. Now, to identify whether it converges conditionally or absolutely, we have to analyze the convergence of this series. And this time I'm just going to use the comparison test. I can use the limit comparison test too, but you will see that when comparison test is applicable, it is less work than the limit comparison test, although the limit comparison test is more powerful. This series is less than this series, which is a geometric with a common ratio 1/9, which is less than 1. Therefore, this series converges. Now, by the direct comparison test, the original series here converges. And therefore, the original series in the problem converges absolutely. And that's the answer. Another problem. So I'm just gonna, because we have negative there, I'm just gonna throw that negative inside of the that alternating sign term. And this is alternating series, so we're gonna set up the alternating series test first. It's positive and maybe decreasing, so we set up the limit, and then goes to infinity of 1 over 5 n to the power 4/5. This limit is equal to 0. So we check this condition, check this condition. So this original series converges by the alternating series test. Now, to check whether it converges conditionally or absolutely, we analyze the convergence of this series. And this series is literally an example of P series when P is equal to 4/5, which is less than 1. which means actually less than or equal to 1. Right, which means that it diverges. And because it diverges, the original alternating series converges conditionally. And we finished the homework. If you have any questions, please let me know.